Welcome to today's lecture. Today we're going to study about combinational logic. In the last class we did study about some of the error correction and not error correction but parity bits and also error checking. Okay, so this class we would be talking about combinational logic. What is combinational logic? What is the use of that? And what are the different methods followed for obtaining a combinational logic for a given task. Okay, so combinational logic simply it has a simple input, internal logic gates, and output. Up to now, whatever you have studied as of simple logic circuit is we can say that those are simple combinational logic circuits. Okay. Now, second point, it doesn't have any kind of memory or storage element. I will give examples for that, but you just keep in mind these points. It doesn't have any kind of a memory or storage element, and it doesn't even has any kind of feedback also. Okay, if we combine the last 2 points, we can say that a logic circuit or combinational logic circuit that has all these 2 points built in, if it does have these 2 points built in, we're going to say that to be a sequential circuit. Okay, a combinational logic circuit that has last 2 points built in, we're going to call that sequential circuit. If it doesn't contain last 2 points, we're going to say that it is combinational logic. Okay, we will get into in brief with sequential circuit, but for now only concentrate on the definition for this combinational logic circuit. Okay, so it has input, internal logic gates, and output. It doesn't have any kind of memory or storage element, and it does have no feedback. Okay, so we will get into the example for this. See, any kind of combinational logic circuit, we have to analyze that. So I'm going to now explain you the analysis procedure that is defined. You will get into the book and you will find that under combinational logic there is an analysis procedure. Now what do you mean by that analysis procedure? Is how to analyze that particular combinational circuit. What does the combinational circuit does? Okay, I have taken an example for this. This is an example of the combinational logic. You see there is two output, there are multiple inputs, for example A, B and C. These are the inputs, and on the internal you have logic gates, and that's exactly what was the definition is. It has output, it has input, it has logic circuits in between, but there is no feedback or memory storage element. Okay, on logic gates we have we have different types of logic circuit that can store actually bits of data, and we're going to call that as memory elements, but in this particular example there is no such elements and there is no feedback also. Okay, if you see any gate here, it has one input, one type of input that is not related to output in any way. So that's why we call it or we call it as a simple no feedback circuit. Okay, if you consider this gate, you see the input to this gate is dependent on this one and this one, not on this one. So indirectly we can say if the output is not dependent on if the present output is not dependent on the future output, then we're going to say that there is no feedback, or simply by looking at the figure you can say that there is no feedback. Okay, so this part is your logic diagram. We call it as a logic diagram. Okay, this one is a logic diagram, and this is the first step for your analysis procedure. If the logic diagram is given to you, you have to identify the inputs and also identify the outputs. Okay, and we call it the logic diagram. This is the first step for the analysis procedure. The second step would be your logic expression. That the first diagram is your logic diagram that diagrammically explains you the operation, but we need logical expression to mathematically represent them, and this is pretty easy. By looking at the figure you can define what are the different outputs and inputs. Okay, we have overall 2 output and 3 inputs, but in between every logic gate has one input, multiple input and one output. So we're going to name them. For example, this part we have A, B and C. This one is T1 and T2. Those are the input to this particular logic gate. For this logic gate we have F2 dash, F2 complement and T1 as input, whereas T3 is the output. For this logic gate, T2 and T3 is the input. Okay, so we have to label all the input and output in between, and we have to find the expressions for them accordingly. T2 here is going to be A, B, C and together, and that is I guess that is right here. Okay, this is the T2, that is the AND operation, all of the 3 inputs, and accordingly you're going to define all the inputs and find the expressions for them. F1 is T2 plus T3. I have simplified that to this particular expression, final expression. Okay, you can substitute the values of T3 here, which is going to be F2 complement dot T1, and T1 is also A, B plus C, and F2 dash is also given, F2 is given here, and F2 dash is the complement of that, and thereby you're going to find the final expression accordingly. Okay, and A, B, C are also given here. So by simplifying you will find the F1 to be a simple expression of this. Okay, so this is your second step for the analysis procedure of any combinational logic that is given to you. And the third and the final step would be to formulate the logic table or the truth table. So this is simple. You just take the inputs on one side of the logic table and outputs on the other side of the logic table. You have to evaluate each expression manually, and you have to tabulate them according to the particular combinations. Each particular combinations you have to define all the outputs, and the expressions for them are also given here. So this is your analysis procedure. Okay, overall this is your analysis procedure for any combinational logic that is given to you. And combinational logic is simply has input and output, and there is no memory element or feedback. Okay, we call it as combinational logic.